Another one of Dr. Compare's team. Developing countries lack the ability to provide electricity to rural areas. Solar energy will be harnessed to generate up to 1 kilowatt of electricity into developing areas using solar thermal energy. Please welcome the organic Rankine cycle.
Good morning, everyone. My name's Brandon.
I'm Travis. I'm Adam.
I'm Ram. I'm Eric.
And I'm Christina.
And we're the Organic Rankine Cycle Group.
So I'm sure you all know this. There's a huge need for electrical power in Africa or other third world areas. And so I guess, yeah. All right, so there's a huge need for electrical energy. Only 20% of the population in Africa has direct access to electrical energy. And with our project, we hope to increase the usage of electricity. And according to a study done by the UN, that electrical energy and power is vital to the development of Africa. And with our project, we hope to push along this development.
Now that we've explained to you the overall purpose behind our project, we'd also like to share the goals, which were the driving factor behind our design. Overall, our main goal was to produce 1 kilowatt net power. We also would like to produce hot water. Also, there are some limiting factors behind our design. We basically want to keep the cost really low so that a third world country can afford this. So we're using used car parts and readily available materials. We also would like to have our system located near a fresh or a pond or a water source, which we will use that water as part of our cooling in the condenser.
Here's a diagram of our system. And basically what happens, we have water that goes through each of these main devices and undergoes 4 different processes. In the turbine, we have water is expanded and causing a shaft of the turbine to spin, and the spinning shaft is connected to an alternator. This alternator spins and generates electricity, which is stored in a battery. After that, the water then goes to a condenser, where the water is cooled using the nearby lake water, and the outlet of this lake water from the condenser will be hot, and we'll store that and use that for further applications. The water then travels through a pump where the pressure is increased and it helps flow the fluid throughout the system. Then our water will go to the boiler, and this is where our interaction is with the solar trough group. As the solar trough group mentioned, they'll utilize the sun to heat a fluid. That fluid will be passing through our system, heating our water, turning it into steam. The steam will go through the turbine, and the process will repeat itself. And here's a picture of a preliminary developmental stage of our system, and for the final design, you can go visit booth number 8 in the back, and we'll be happy to answer any questions you have there.
There are a few improvements that can be made to the current design of the microgenerator. One such improvement is to increase the efficiency overall of the system. This can be done by increasing the temperature input to the system and to reduce the energy loss throughout the system, such as using insulation to minimize the heat loss to the atmosphere. Another improvement is to exchange some of the components that we use. We need to find some more readily available, more cost-effective components to bring down the cost even more and to make it much more economically feasible for it to be used.
Some practical applications could include to provide lighting in areas where normally the sun is the only source of light, cooling in areas where air conditioning is not available. It could even be used for educational purposes to power computers or to aid in construction processes by powering power tools. Hot water could be used for washing dishes, cleaning clothes, and even bathing your children.
Here are our individual responsibilities for our group. Brandon was our group leader. Travis took care of all the electrical systems. Adam handled all the pumps. I handle all the turbine systems. Eric did most of the boiler and condenser designs, and Nina was a hardware specialist. As you can see, also we're all mechanical engineers, but we have diversified options. We did energy systems and mechanical systems. Like that diversity actually helped us a lot in our design. So
We'd like to thank our sponsor, Progress Energy, and of course the support from Dr. Compare and the MMAE department. And if you guys have any questions, please feel free to visit us, booth number 8 in the back. Thank you.